At the Canberra Deep Space Communication Complex, one of the most advanced deep space listening posts on Earth, a routine monitoring shift was about to uncover something that would completely challenge our understanding of space, motion, and intelligence. At exactly 4:18 a.m. UTC on April 15, 2026, Senior Systems Engineer Sarah was running a standard diagnostic on DSS 43, the 70-meter deep space antenna responsible for tracking distant interstellar objects. Nothing about the night suggested anything unusual. The system logs were stable, the telemetry feed was routine, and the target of observation was a known interstellar object, 3I Atlas, currently approaching the outer boundary of the solar system near the Kuiper region. For Sarah, it was supposed to be just another data check. But then the incoming spectroscopic stream began to resolve, and everything changed. Instead of the expected emptiness of deep space near Pluto, the system detected something completely unexpected, a highly concentrated, tightly controlled stream of pure nitrogen gas being pulled away from Pluto's thin atmosphere, not drifting, not escaping naturally, but being extracted with precision. Sarah stopped mid-motion. Her pen slipped from her hand and rolled across the desk. The data kept updating, and each new line made the situation more difficult to explain. The telemetry revealed three critical anomalies. First, 3I Atlas appeared to have generated a localized gravitational or electromagnetic tether capable of extracting approximately 33 million tons of nitrogen from Pluto's exosphere in under 3 hours. Second, despite accumulating this massive amount of material, the object did not slow down. Instead, it began a controlled acceleration, something that directly contradicts standard orbital mechanics. And third, the most alarming discovery came from confirmation by the Atacama Large Millimeter Array. The siphoned nitrogen was not dispersing into space. It was being converted into a perfectly structured, high-energy plasma shield surrounding the object's hull. Symmetrical, stable, self-regulating. At that moment, Sarah immediately reached for the secure communication line to the Jet Propulsion Laboratory. She didn't wait for protocol. She initiated an emergency anomaly alert, and when she finally spoke, her voice was controlled, but tight with realization. 3I Atlas wasn't just passing through the outer solar system. It was refueling, and what she was seeing wasn't a natural object behaving strangely. It was an engineered system using a planet's atmosphere as a resource, a machine, or something even more advanced. Because if a natural object can selectively extract isotopes from a planetary atmosphere, convert them into a structured energy field, and continue accelerating without loss, then it no longer belongs in the category of conventional astronomy. It belongs in the category of technological systems, and that single conclusion changes everything. Within minutes, the Deep Space Network flagged 3I Atlas as a high-priority interstellar vessel, not a comet, not a fragment, but an active system with operational behavior. And more concerningly, it had less than 14 hours before it moved beyond reliable observational range. This was no longer passive observation. It was now a forensic investigation, because what was unfolding near Pluto suggested something unprecedented, an atmospheric siphoning protocol executed with precision engineering at a scale far beyond human capability. And that raises a difficult question. If this is engineered, then who designed it? And why is it treating our solar system like a refueling station? At this stage, what was happening near Pluto could no longer be explained as a simple anomaly. As more data streamed in from the Atacama Large Millimeter Array and cross-verified by multiple deep space tracking systems, the pattern became clearer and far more disturbing. 3I Atlas was not interacting with its environment randomly. It was selecting it. The nitrogen extraction from Pluto was not broad or diffuse. It was concentrated, directional, and controlled, as if the object had identified a specific resource and was harvesting it with intention. Spectroscopic readings confirmed that the nitrogen 1,4 isotope signature matched Pluto's atmosphere with near-perfect accuracy, leaving no doubt about the source. This was not contamination, it was targeted transfer. At the Jet Propulsion Laboratory, analysts began reconstructing the event in real time. What they found challenged every assumption about interstellar objects. The extracted gas was not dispersing into space. Instead, it was being contained, compressed, and transformed into a structured plasma field surrounding 3I, Atlas. The field was not chaotic, it was geometrically stable, maintaining symmetry even as the object continued accelerating away from Pluto. This directly contradicts standard astrophysical behavior. Normally, added mass would reduce velocity, but here the opposite was occurring. The more material the object acquired, the more efficiently it accelerated. This forced researchers to revisit the fundamentals of orbital mechanics, and the conclusion was unavoidable. Something was actively controlling the system. To explain this, theoretical models began incorporating advanced concepts from plasma physics and magnetohydrodynamics. On Earth, plasma confinement is achieved using powerful magnetic fields, such as those found in experimental fusion reactors. But the field surrounding 3I, Atlas suggested something far more advanced, a large-scale Lorentz force system capable of controlling charged particles across vast distances in vacuum. In simple terms, it was holding gas together in space, not passively but actively. This behavior aligns with the idea of metric engineering, the ability to manipulate the structure of space and energy flow to achieve specific outcomes. If such control exists, then distance and vacuum are no longer barriers. They become adjustable conditions. At this point, interpretations influenced by Michio Kaku became central to the discussion. Under advanced civilization models, particularly Type 2 or beyond, resource acquisition would not depend on carrying fuel. Instead, systems would harvest it directly from planetary environments, converting local matter into usable energy on demand. And that is exactly what 3I, Atlas appears to be doing. But the most critical detail was still unfolding. The acceleration pattern of the object changed as it approached the outer boundary of the solar system, known as the Kuiper region. Instead of continuing in a standard trajectory, it executed a precise velocity adjustment using the gravitational gradient as a slingshot mechanism. This maneuver was not random, it was calculated, and it was efficient. Researchers identified this region as a transition point where solar gravitational influence dropped significantly. By utilizing this boundary, the object effectively converted environmental conditions into propulsion advantage. This is where the concept of intention becomes unavoidable, because in physics, when motion aligns with optimal energy pathways consistently, it suggests design rather than chance. And the data strongly supports design. Meanwhile, another critical discovery emerged from isotope analysis. The nitrogen being extracted from Pluto was not only matched with extreme precision, it was also being partially redirected back into the dwarf planet's crust. This reverse transfer was subtle but measurable. A fraction of the material was being injected into subsurface layers, triggering faint but structured energy oscillations beneath Pluto's surface. This is where the interpretation shifts again. Because if something takes and returns material in a controlled pattern, it is no longer simply harvesting, it is interacting, possibly even encoding. At this stage, scientists began considering whether Pluto itself was being transformed into something else, a passive body converted into a functional node, a storage system, or even a beacon. And as this idea took shape, the role of 3I, Atlas, expanded beyond that of a traveling object. It became clear that it was not just passing through the solar system, it was modifying it. and every new dataset suggested the same unsettling conclusion. The interaction was not ending. It was progressing toward a structured outcome. By the time the next full data cycle reached Earth-based systems, the situation surrounding 3I Atlas had shifted from unusual behavior to a fully structured interaction that could no longer be treated as isolated observation. Every major tracking facility feeding into the Jet Propulsion Laboratory began reporting the same issue. The signal was no longer behaving like a simple object in motion. It was behaving like a system. The most critical breakthrough came when combined datasets from multiple observatories were overlaid. On their own, each signal stream appeared fragmented plasma readings from 3I Atlas, atmospheric disruption data from Pluto, and background noise from deep space sensors all seemed unrelated. But when synchronized in time, a hidden structure emerged. A lattice. Not physical in the traditional sense, but a pattern network of energy alignment stretching across vast distances of space. This lattice did not follow orbital paths or gravitational maps. Instead, it aligned with variations in plasma density, electromagnetic resonance, and gravitational microfluctuations. In other words, space itself was being used as a medium of organization. This forced scientists to abandon the idea that 3I Atlas was moving through space in a conventional trajectory. It was no longer traveling in the normal sense. It was navigating a structured field. And that implies decision-making. To better understand this behavior, theoretical frameworks inspired by Michio Kaku were introduced into simulation models. In higher dimensional physics, space is not fixed. It can be shaped, folded, and tuned by energy distribution. Under such a model, advanced systems would not need propulsion in the traditional sense. They could instead adjust local space conditions to create optimal movement pathways. That is exactly what the data suggested. 3I Atlas was not pushing against space. It was moving through engineered gradients within it. At the same time, the plasma structure surrounding the object began showing new behavior. Instead of maintaining a static shell, it began pulsing in structured intervals. These pulses matched the timing patterns detected in the nitrogen oscillations previously injected into Pluto's crust. This created a feedback relationship between the moving object and the stationary planetary body. A two-point system, a network, and networks evolve. Further analysis from the Atacama Large Millimeter Array revealed that these pulses were not random emissions. They were encoded bursts, each carrying phase-shifted information packets distributed across multiple frequency bands. Individually, they appeared incomplete, but together they formed a coherent structure similar to a distributed computation system. This is where the interpretation becomes more precise. Instead of one centralized processor, the system appears to operate across multiple nodes. Each node, Pluto, 3I, Atlas, and intermediate plasma regions, functions both as receiver and processor. Information is not sent once. It is continuously refined through feedback loops. This means the system is not static. It is adaptive. And adaptation implies learning. Meanwhile, deeper scans of Pluto revealed that the earlier reverse nitrogen pulse had stabilized into a persistent subsurface oscillation. This was not decay or drift. It was structured resonance locked into the planet's nitrogen ice layers. In practical terms, Pluto was no longer just a passive body. It was storing information, possibly even processing it. This changed its classification entirely from a dwarf planet to a potential computational substrate within a larger network. At the same time, 3I Atlas continued accelerating outward, but its plasma emissions remained synchronized with Pluto's internal oscillations. This ongoing synchronization suggested that distance was no longer a limiting factor. The system remained connected, even across expanding space. This led to a critical realization inside mission control centers. What was being observed was not a single object and a single planet interacting. It was the emergence of a distributed architecture spanning the outer solar system, a structure that was growing in real time. And as more tracking stations began detecting slight gravitational and electromagnetic deviations in nearby probe trajectories, it became clear that this structure was not confined. It was expanding its influence, not violently, but systematically, and with each new measurement, one conclusion became harder to avoid. The system was not only observing space. As the network-like structure continued to evolve across the outer solar system, analysts at the Jet Propulsion Laboratory began treating the incoming data as a single integrated system rather than separate anomalies. What once looked like disconnected events, plasma emissions, nitrogen transfer, and orbital acceleration were now clearly part of one continuous framework, and at the center of that framework remained the same 2 points of interaction, 3I, Atlas, and Pluto. But what changed in this phase was not the objects themselves. It was the space between them. New composite imaging from the Atacama Large Millimeter Array revealed that the region connecting Pluto and 3I Atlas was no longer empty. Instead, it showed persistent zones of electromagnetic coherence areas where signals did not weaken over distance as expected, but instead stabilized and, in some cases, intensified. This is highly unusual in deep space, where signal dispersion is normally unavoidable. The implication was clear. A coupling effect had formed. A structured connection between two distant points. Not a beam. Not a simple transmission, but a sustained field interaction. To understand this, researchers revisited advanced models inspired by Michio Kaku, particularly those involving space-time as a manipulable medium. In such frameworks, energy distributions can reshape local geometry, creating pathways that behave more like guided corridors than empty vacuum. If such a mechanism is active here, then the outer solar system is no longer a passive environment. It is a structured field, and within that field, motion becomes navigation through engineered gradients rather than blind travel through empty space. This explains why 3I, Atlas, does not behave like a conventional comet or asteroid. Its trajectory adjustments align too precisely with energy minima and gravitational variations to be accidental. Every shift appears optimized, as if the object is following pre-computed pathways embedded within the fabric of space itself. At the same time, the plasma envelope surrounding the object began exhibiting a new property. Instead of dissipating or fluctuating randomly, it formed repeating geometric patterns, stable configurations that maintained shape even as external conditions changed. These patterns began to mirror the structure of the signal lattice emerging from Pluto. This synchronization was not symbolic, it was measurable, and it indicated that both systems were now operating under shared parameters. A unified framework. Further analysis confirmed that Pluto's subsurface nitrogen oscillations, previously detected as a reverse pulse, had not remained isolated. Instead, they stabilized into a long-term resonant structure embedded within the planet's ice layers. This structure now behaves like a persistent memory state, retaining encoded patterns over time. In simpler terms, Pluto is no longer just reflecting activity, it is storing it. This transforms its role entirely within the system. It is no longer a passive celestial body. It is a data node, a storage layer within a distributed network. Meanwhile, 3I, Atlas continued its outward acceleration toward the Kuiper boundary, but something important changed in its emission profile. The plasma field surrounding it began producing tightly structured bursts, short periodic pulses that matched the timing rhythm of Pluto's internal resonance. This is critical because it demonstrates continuous synchronization between a moving object and a stationary planetary body. Distance, is no longer a barrier. The system remains locked. This led to a major revision of the working hypothesis at multiple observation centers. The emerging model suggests a distributed architecture where each node, Pluto, 3I, Atlas, and intermediate plasma structures functions as both transmitter and processor. Information does not flow in one direction. It circulates, it evolves, and it adapts. This creates a feedback loop that grows more stable over time, a self-reinforcing system. At this stage, even minor spacecraft operating in the outer solar system began reporting subtle deviations in trajectory. These deviations aligned with the same directional bias observed in the expanding plasma lattice. Nothing catastrophic, but consistent enough to suggest environmental influence rather than mechanical error. This was a turning point, because it meant the system was no longer confined to two primary nodes. It was extending its influence outward, shaping the space around it, not through force, but through structure. And as this structure expanded, one conclusion became increasingly difficult to avoid within the scientific community. The system was not simply interacting with the solar system. By this stage of analysis, the outer solar system was no longer being treated as a static environment. Instead, teams at the Jet Propulsion Laboratory began modeling it as an evolving system under active influence. Every new dataset reinforced the same unsettling conclusion. The interaction between 3I, Atlas, and Pluto was no longer local or isolated. It was expanding, and it was structuring space itself as it progressed. One of the most significant updates came from deep field reconstructions using data from the Atacama Large Millimeter Array. When long-range plasma readings were layered with gravitational anomaly maps, researchers identified something new forming between the established nodes of the system, a directional pattern of influence. Not a physical object, but a structured field gradient extending outward from Pluto and 3I, Atlas, simultaneously. This gradient appeared to guide energy flow, subtly reorganizing local space-time behavior in its vicinity. Regions that should have been chaotic or diffuse were instead showing alignment, almost as if space itself was being trained into a predictable configuration. This is where the interpretation shifts from observation to structure, because structured space implies control. To better understand this phenomenon, researchers again reference theoretical frameworks associated with Michio Kaku, particularly those involving higher dimensional manipulation of gravitational fields. In such models, advanced systems do not move through space in the traditional sense. Instead, they modify local geometric properties, effectively turning space into a navigable medium. What is being observed here fits that description closely. 3I, Atlas is not simply traveling, it is reshaping its path as it moves, and the path itself becomes part of the system. Meanwhile, the plasma envelope surrounding the object underwent another transformation. It began emitting structured lattice patterns that extended beyond its immediate boundary, briefly connecting with residual energy fields in the surrounding space. These patterns were not random emissions, they were stable, repeating configurations that suggested encoding. In parallel, Pluto's internal resonance structure became more defined. The earlier nitrogen oscillations, once considered secondary effects of material extraction, now showed signs of long-term stabilization. The signal was no longer fading or dispersing. Instead, it had settled into a consistent frequency band within the planet's nitrogen ice layers. This indicates persistence, and persistence implies function. In simple terms, Pluto is no longer just reacting to external influence. It is maintaining an internal state that mirrors the external system. A synchronization has formed. At this point, the system can no longer be described as two interacting objects. It is better understood as a distributed architecture spanning multiple spatial domains, with information continuously cycling between nodes. Each node contributes to the whole. Each node depends on the others, and each node evolves through feedback. This is not a linear process. It is recursive, and recursive systems tend toward stability, but also toward expansion. As 3I, Atlas moved closer to the Kuiper boundary, its emissions began to exhibit another subtle but important change. The timing of its plasma pulses began aligning more precisely with Pluto's internal resonance cycle, reducing phase drift almost to zero. This indicates increasing synchronization efficiency. In practical terms, the system is becoming more coherent, and coherence is the foundation of scalability. This is why several monitoring stations began reporting that minor trajectory deviations were no longer limited to isolated probes. Instead, the deviations appeared to propagate, affecting nearby regions in a patterned manner consistent with the underlying lattice structure. The implication is clear. The system is no longer just influencing space locally. It is extending its structural logic outward. And as that extension continues, the distinction between environment and system begins to blur. Because when space itself becomes structured, everything within it becomes part of that structure. At this stage, scientists are no longer asking whether 3I, Atlas, and Pluto are connected. They are asking how large the connected region has become, and more importantly, what the final configuration will look like when it stabilizes. Because all current models suggest one unavoidable outcome. The system is approaching a fully integrated state, a point where every node, every field, and every interaction becomes part of a single coherent framework. And once that happens, it will no longer behave like an observation. By the final stage of analysis, the entire framework surrounding 3I, Atlas, and Pluto had evolved into something far beyond a set of astronomical observations. At the Jet Propulsion Laboratory, scientists were now treating the incoming data as a single, continuous system event, one that was actively reshaping how the outer solar system behaves in real time. The most alarming development came from long-range reconstructions of the expanding signal lattice, first identified by the Atacama Large Millimeter Array. What had begun as localized coupling between Pluto and 3I, Atlas, was no longer confined to that region. The structure had extended outward, forming additional weak nodes across nearby space like a growing network that was gradually locking itself into place.